Welcome to the Macrosystems EDDI module using high-frequency data to manage water quality. This module has been developed in collaboration by water treatment instructors at Mountain Empire Community College and freshwater scientists at Virginia Tech. The module is part of the Macrosystems EDDI program, which stands for Environmental Data-Driven Inquiry and Exploration, and is supported by a grant from the United States National Science Foundation. This module includes 3 activities, which are all designed to introduce concepts related to assessing water quality and collecting high-frequency water quality data. In Activity A, students will access and explore high-frequency water quality data from a drinking water reservoir in Southwest Virginia. In Activity B, students will use high-frequency water quality data from the reservoir to make water treatment plant operation decisions regarding extraction depth. In Activity C, students will make water treatment decisions using forecasts of water quality. All of the activities are designed to address the focal question for this module, which is, how can we use high-frequency data to improve water quality? To address this question, we first need to understand what is meant by water quality. Water quality has 2 components. First, the suitability of water for human uses, such as drinking, recreation, irrigation, and so on. Second, the ability of the water body to support important ecosystem processes, such as sustaining a healthy fish population. High-frequency water quality data are measurements of various attributes of a water body, such as temperature, dissolved oxygen, pH, and so on, that are taken many times during a day or during a week, for example, every 10 minutes. This is different from low-frequency data, which are only collected perhaps once a week or even once a month. High-frequency data allow water managers and scientists to observe and analyze patterns and trends in water quality that were not previously visible using low-frequency measurements. For example, the plot on the bottom of the slide shows water temperature data collected from many different depths in a reservoir every day over the course of a year. You can see there is a lot of variability in these data that would not be visible if the data were collected once a month, for example. High-frequency water quality data are often collected using automated sensors. These sensors are deployed in a water body attached to buoys, catwalks, or other structures and collect data continuously. Many of these sensors are automated, which means they can wirelessly stream data to a computer so that it is available to managers in near real time. Today, we are going to explore high-frequency water quality data from drinking water reservoirs in Southwest Virginia, and then use that data to make water treatment plant operation decisions. For the module, students will explore high-frequency water quality data collected using several different sensors. For example, some of the data are collected using a YSI XO sensor, which is pictured on the bottom right of the slide. This sensor is deployed at a fixed depth in the reservoir attached to a catwalk. In this module, students will work with turbidity data collected by this sensor. In addition to turbidity, you will also explore water temperature and dissolved oxygen data, which are collected at multiple depths in the reservoir. On the right is an example figure of water temperature, dissolved oxygen, and turbidity data collected from multiple depths in a drinking water reservoir during the summer. You will learn how to interpret these data and understand how the data can be used to assess water quality. You'll have the option to explore data from one of 2 reservoirs located in Southwest Virginia, Falling Creek Reservoir or Beaver Dam Reservoir. Both reservoirs are located in Vinton, Virginia, near Roanoke, and are owned and operated by the Western Virginia Water Authority as drinking water supply reservoirs. You will use high-frequency data from your chosen reservoir to make water treatment plant operation decisions. In Activity B, you will use high-frequency water quality data to make decisions about water extraction depth for a drinking water treatment plant. In Activity C, you will use water quality forecasts to make decisions about water treatment to ensure that your plant meets regulatory standards for turbidity on the bottom filter. This module has 4 learning objectives. First, that you will define key measures of surface freshwater quality. Second, that you will explain how water temperature changes over the course of a year in a temperate reservoir and how these changes affect water quality. Third, you will interpret high-frequency water quality data to make decisions about water extraction depth for a drinking water reservoir. And fourth, you will evaluate water quality data and forecasts to make decisions about drinking water treatment. I'll now give a brief overview of the module activities. In Activity A, you will complete 2 objectives. First, you will select and learn about a focal drinking water reservoir. Second, you will explore real-time high-frequency water quality data from your chosen reservoir. In Activity B, you will use high-frequency water quality data to make water withdrawal depth decisions at different times of year. Then you will be introduced to key concepts related to water quality forecasting and learn how to interpret a forecast for fall turnover in a reservoir. Finally, in Activity C, you will complete a scenario which asks you to make water treatment decisions using water quality forecasts. You will complete this module using 2 different web pages. The module can be accessed through your course Canvas site. From that site, you will then be linked to another interactive website, which is called an R-Shiny app, and that is where you will complete module activities. Be sure to complete the quick start guide to the module and watch the video that explains the interactive module features when you are on the interactive website, which is the R-Shiny app. Questions that are embedded in the interactive website will be answered in a Canvas quiz that you will access through the Canvas website. Thank you so much for participating in Macrosystems EDI. Please check out our other water quality and management module, Module 8, using ecological forecasts to guide decision-making, which can be found at macrosystemsedi.org.